Yeah, so between 7 to 7:30 a.m., bus arrives in 15-minute interval. Right? So comes at 7:15 and then at 7:30. Okay. So what is the probability that a person has to wait for more than 10 minutes? That means uh, because the bus comes at 7:15 and he has to wait for more than 10 minutes, right? So he should arrive, uh, uh, how should I put it, before 7:05. Right? So I prepared a solution. We can assume this is uniformly distributed. We can 7, I just removed it, so it's 0 to 30 minutes. So it's 1 over 30 because it is uniformly distributed. Right? So this represents 7 a.m., this is 7:30 a.m. Right, so this is where the bus comes. So we will wait for more than how many minutes? More than 10 minutes, right? So from 15 go back to 10. We should wait for more than 10 minutes. It means we should arrive before 5, 7, 5. And the same logic goes for this thing, 7:30, right? So here we should be uh, coming less than this thing. Uh, 10 minutes, it is 20, right? 15 to 20. I mean, you should miss that bus at 7:15, right? And between this to this, if he comes, he'll wait more than 10 minutes, right? So that's the probabilities you can be between 0 to 5, right? That is x less than 5, and the probability between 15 to 20. So that's it. So just because it is uniform distribution, you just find the area between 0 to 5, that is 5 by 30, and between 15 to 20, that is again 5 by 30. That's 1 by 2. Clear? Is the explanation clear? Why finding probability x less than 5? Okay. So if you notice, the bus comes at 15 minutes, right? And you want the event that you will wait for more than 10 minutes. So when the bus comes at 15, right, you will wait for exactly 10 minutes when you arrive at 5. When you arrive less than 5, say 4 minutes, you will wait for 11 minutes. Well, that is precisely the event you want, that you should wait for more than 10 minutes. So in this region between 0 to 5, if you arrive, you will end up waiting more than 10 minutes. So same thing, you compute because bus arrives at 30, again at 15 minutes, right? At 30 minutes, 7:30, right? And you already missed the bus at 7:15. So that means you have to wait for more than 10 minutes for the next bus. You should be coming here after 15 and before 20. 7 after 7:15 and before 7:20. Is it clear? So the second question is a bit involved today. Others are pretty simple. So two people, Aditya and Ayush, work independently on a problem. So this is important, independent thing here. Okay. The time for Aditya to complete a problem is exponentially distributed with mean 5 minutes, and time for Ayush to complete a problem is exponentially distributed with mean 3 minutes. And which of the following are correct? So basically, all three are correct here. So let's see how do we go about it. Now, probability that Aditya finishes the problem before Ayush, right? So you know that Aditya is exponentially distributed with some mean, Ayush is exponentially distributed with some mean, right? Call it x, y, and names as lambda 1, lambda 2. Basically, what we want is what is the probability that x is less than y? That is, Aditya's time is lesser than Ayush's time. Formalize everything now. Here. So AD is Aditya, AY is Ayush. You can assume that. Their ability of solving problem exponentially distributed, right? With exp of lambda 1. So when I write exp of lambda, here mean is 1 by lambda. Okay, I hope that is conveyed. And Ayush is distributed with mean lambda 2, that is given as 1 by 3. And you want this event. What is the probability that x less than 1? Okay. So what is this event? How do you do this event? We use the conditional probability. Okay, so you condition on some y, basically, right? On some value of y, and you get this term, right? And to get the overall probability, you need to average out all the values of y, right? So is this clear? This is important. This part is important. Is that expression clear? If not, I'll again iterate. First step in this one, right? Okay. So um, here, this is probability of x less than y. This is a random variable, right? And you are expressing uh, the random variables as a how should I put it? By using the total probability. Okay, so p of x. So if you have a density f of x comma y, right? You want to get f of x. So how do you write it? So you do f of x1 and you integrate with respect to dx. You marginalize the x term, right? So this is analogous to that. So basically what we are doing is we want to see suppose y takes some value y, right? And then we want to find the probability of that. So that is precisely this thing. Now because this is only for a given value of y, to get the entire probability, we want to integrate across all the values of y. This is nothing but average in for all values of y. That is precisely is probability x less than y. Okay, it's clear, right? That is very important step. You keep using this thing again and again today. Okay, so how the y goes, the range of y is 0 to infinity because it is exponential distributed. Right? And so here, what I've used is the definition of the CDF of exponential random variable. Right? Probability x less than x for an exponential random variable with parameter lambda is 1 minus e power minus lambda x. Right? You should be familiar with at least the basic distribution. Um, right? So this is just the formula. But notice one thing, that is the formula for probability x less than y. Right? So probability some x is less than alpha is nothing but 1 minus e power minus lambda 1 alpha. But here I have a conditional distribution. But still, even then I'm writing it like this. Why is that? Any guesses? Okay, so that is because this quantity probability x less than some small y given y is equal to y is equal to probability x less than y because x and y are independent. So that's why in the beginning I said independence is important. If that were not, you wouldn't have this kind of expression. It would have been something else, depending upon how that dependence is being modeled. Okay, so That's it. Now we have a straightforward calculation here. So 0 to infinity, just integrate this out, and again same thing, 0 to infinity, integrate this out. You get 1 minus lambda to the lambda of this lambda. So the first answer is 3 by 8. Probability x less than y is 3 by 8. Any questions? This is the most important step. And this, again, writing this independence thing, right? This is also very crucial. Everything else is trivial here. Okay, we'll go to second question then. Second part then. If this is okay. Okay. So the second part is continuation of this, right? So what is the second question is, given that Aditya requires more than 1 minute, you know that you cannot complete the task in 1 minute, and you want to know the probability that he finishes the problem before Ayush. So same problem, right? X less than y, but it is now condition that x is greater than 1, right? You are given more information now. Okay, so this is again P of A given B is P of AB given by P of B, right? So that is a simple conditional probability definition. Okay, the first step. Second step, now notice just from x less than y changes to 1 less than x less than y, right? Just for a meanwhile, let's forget about this thing. We want to compute only the top one. Okay. Again, the same thing, right? Conditioned on y, use the total probability rule and marginalize with respect to y for every value of y. Right? That's why I said this is important. Okay. So again, one more thing, because x and y are independent, this quantity probability that 1 less than x less than y given y is independent of y. Okay? That is equal to probability 1 less than x less than some small y. Okay, and since we know that for any say continuous distribution, probability that a less than x less than b is given by f of b minus f of a, where f is your CDF, right? So that's what I have used here. Okay. So I used two things. One is x and y are independent, and another one I've used is this probability a is less than x is less than b is fx of b minus fx of a. So fx of y minus fx of y. What is fx of y for an exponential distribution? 1 minus e power minus lambda 1 y. Same thing, you end up with this, right? Only this term I have expanded. Okay? You have to integrate with respect to all the values of y. Okay? So just integrated it, and yeah. So this is just some manipulation, and remember here the limits of y are 1 to infinity, not from 0 to infinity. Okay, so I think while I was computing, I just kept 0. That was not correct. So, right, you have to put from 1 to infinity. Just manipulate it, you end up with this. But remember, there is division by probability x greater than 1. So, one more thing is probability x greater than x, or some probability x greater than alpha for exponential distribution is e power minus lambda alpha. In this case, e power minus lambda 1 times 1. So that's why I've divided in the last with e power minus lambda. Okay, so you end up getting it this. Any question on this? I can go over any parts if you did not follow. So only the first part is very crucial. You follow it, it's just a simple algebra. Cool. Mm, I mean, third problem, right? So this is an interesting phrase in there. Given probability that one finishes the problem a minute or more than the other one. Okay, so here you want the problem is probability that Ayush finishes the problem a minute uh, or more before than the other one, right? Because then probability that one finishes the problem a minute or more. So here we want like x is less than y minus 1 and y is less than x minus 1, right? A minute or more before the other one, right? So yeah, these two events capture uh, that probability. So concisely, you can say that the difference is at least one, right? Is this step clear? Okay. So mm, again the same thing, right? I have done for only one thing, and by symmetry I have written for the second term. Okay. So here probability x is greater than 1 plus y is again same thing, right? Again I condition on y, again I will integrate it for all the values of y. Again I use the independent step here to write this thing, right? Um, yeah, again it's just a matter of simplification. E per minus lambda 1 times lambda 2 by lambda 1 plus lambda 2. For the other, just by symmetry, replace lambda 1 with lambda 2. That's it. So this is your desired answer. Okay, so I think this was the only time taking question in this assignment, but nonetheless interesting. Mm. Okay, so before we move, any other question on this? Okay, so so now this is another question where you have Poisson distribution, not Poisson, sorry. Um, the random variable x is Poisson distributed, but the parameter lambda, which is mean of the Poisson, is again a random variable, and that random variable is a gamma distribution. Okay, so now um, you want to know what is the probability that your random variable x takes a value k. In this case, it is the x. The question clear? It's confusing because x is a random variable and x has a density which has a parameter lambda. Again, lambda is again a random variable, right? And you want to know what is the probability x takes a value of k when lambda is a random variable. Lambda is also a random variable, exactly. That's where is the whole thing. Okay, and lambda is distributed a gamma distribution. Okay, you want to think about it, or let you want to go to the solution? It is the same thing that I have been um, using used in the earlier problem. The trick is same. Anyway, let's see. Right. So this is the lambda distribution. Right? This is gamma of n. And now probability x takes a value of x when any lambda, okay, is e power minus lambda times lambda power x by x factorial. Here by lambda here I mean that the random variable lambda is taking some value of lambda. Okay? So again, right, you want the even that x takes value of x small x or k whatever, that's a dummy variable. It doesn't matter. Is again written as your conditional probability on the lambda and integrate all the possible values of lambda. Okay, it is same as saying that your f of x comma y integrated with respect to the other, you get the marginal. Okay, so that's it. And this is the main. This is the main step. Rest of else is all calculation. Just integrate it, substitute the value of this thing here, right? So separate out anything that doesn't depend on lambda, right? You get these things. Again, you have to integrate this. Remember, this is again a gamma distribution, but with some scaled value of lambda. 2 lambda is there, right? So we have a standard formula. If, if suppose lambda is distributed something like this, right? So beta power alpha divided by gamma power alpha lambda power alpha minus 1 times e power minus beta lambda. So this is a gamma distribution in general. So if you integrate with respect to lambda, this entire thing will be 1, right? So just by doing analogy here, so beta is equal to 2 and alpha here is x plus n. Right? This is the standard formula of gamma distribution. Right? So to make this area 1, we need to have this constants appropriately. But those constants are not here, so we just multiply and divide. Right? So this is what we are doing, multiplying and dividing. That's it. So this is the answer. So this after doing that, this will become 1 entire thing, and we are left only with this. That's it. Clear? Okay. Let's go to another question. Yeah, this is again one more tricky question today. It is known that a bus will arrive at a random bus stop somewhere between 8:30 to 8:45. Between say 0 to 15 minutes, right? Say 15 minutes duration. Uniformly, it will come. And the person Rahul decides he will go at random to this location between these times, between that 15 minutes duration, and he will wait at max 5 minutes for the bus. If he misses the bus, that means he'll wait for 5 minutes. If bus doesn't come, he'll take some other route to go to school. Right. So What is the probability that he will not take bus? Just think, I'm just um, keeping this slide just to read and understand the question. We'll go to solution in. Location of location of bus arriving is random. Yes, yes, between that 8:15 to or 8:30 to 8:45 or 0 to 15 minute duration, it can come at any time. And between the same time also this person goes there and he waits for 5 minutes. If bus comes, he'll take, and if bus doesn't come in 5 minutes, he'll take some auto or rickshaw. So the question is, what is the probability that he missed the bus and he takes auto or rickshaw? Right? You can just read one more time before we go to the solution. Okay, so let's go to the solution. So yeah, sorry for this blurring here. Right. I hope you can see. So the event that you are interested is X is the time of arrival of the student. Okay. Yeah, the camera was not good. So yeah, yes, deal with this for today. Okay. This is X. X is the time of arrival of you know of that student or whoever it is, right, between 0 to 15, and Y is denotes the time of arrival of bus between 0 to 15. Now, what the problem says is, or now we are interested in the so we are interested in what is the probability that he finds a bus. So after he comes, bus should come, and after he comes, he'll wait for five more minutes, right? So between this duration, if bus comes, he'll take the bus. That's precisely this um, event, right? X is the time of arrival of this guy, and he'll wait for X plus 5 more minutes. And between this duration, your bus should come. That means Y should happen, right? It is clear, right? This is the probability of finding a bus, but we want the other probability. That is also very easy to see. But let's draw the region of these guys, right? Because they are uniformly distributed from 0 to 15, 0 to 15, right? Y should be greater than X, right? So Y greater than X, Y is equal to X is this line, right? Y greater than X, anything above this thing is Y greater than X, okay? Now Y is equal to X plus 5 is this thing, is this line, right? So between this region, if you fall, you will end up taking the bus, okay? Now, now you have a domain that is between this thing only, right? 0 to 15. Okay. So within this square that I have drawn, this first line and this second line area, right? This total area is your probability of taking the bus. Anything else, that is this triangle area and this triangle area, is your desired event that you end up taking a auto correction. Okay, so that's it. Because it is uniform, you can just compute the area of triangle of this triangle and this bigger triangle and divided by the total area of the square. So that is half times 15 times 15, half times 10 times 10. This is the smaller square area, this is the bigger square area divided by 15 times 15. Okay, so I made a typo here, right? This is 325, but I wrote 355. So that's a typo. And yeah, so that's the answer. It's clear, right? A little bit tricky, but yeah, should be easy. I did not get what do you mean by construction of construct random variable? I mean, this is yeah. That is very important. So you have to model properly the events, right? Even after constructing random variables, modeling the events in terms of these random variables is very crucial. So that simply comes with practice. There is no, I would say, shortcut. Okay, so I think so. This is a simple question. Uh, this is a question on moments. Right? X is a continuous type of random variable. Given that x power r exists, then which of this is the correct one? I mean, if x power r exists, right, all other lower order moments exist, right? But you cannot guarantee that the higher order moments can exist. You can always guarantee that all the lower order moments does exist. Okay, so and now this is a this is a Laplace distribution. So e power minus mod x, e power minus a times mod x, right, f of x. And I mean, you just have to scale it appropriately to make a distribution. So just for positive side, it is e power x, e power minus x, right? And for negative side, it is e power x. So your distribution is symmetric, uh, around zero, right? Zero positive, you have e power minus x, right? It will decrease exponentially, and the negative side also it will decrease exponentially. Right? What is the mean of the absolute value of x? This is very simple, right? Mm, yeah, so this is it. And um, yeah, so this is the expression, then 0 to infinity x e power minus x by 2. When x is positive, that's why we are using this thing. Okay, this is the density. Um, I have made a typo here. Um, Sorry for that. That x by 2. Okay, this shouldn't be there. Here also. Okay, you got it right. I made a typo here. It's not there in the question. It is e power minus x only. And this is e power plus x when x is negative. Okay, so if that is the case, um, it is like 0 to infinity x e power minus x dx. What is it? So if you remember the exponential distribution, lambda e power minus lambda x with lambda 1, that precisely is this x e power minus x. And that is nothing but the mean of exponential distribution with lambda is equal to 1. Right? You have extra half here. That half comes because this is the mean of exponential uh, random variable with lambda 1, right? This is not there. Okay. That's a typo. That shouldn't have been there. So that is half, and this is half. This is symmetric, right? Exactly the negative side. We are doing the same thing, and that is half because we are taking the mod x for mod x, right? And it's the same. Half plus half, that is one. Okay. Basically, this is a Laplacian distribution. There is a name for this. Is there a random variable like having this PDF? Yeah, yeah. So basically, see what is Gaussian? Gaussian is e per minus x square, right? Uh, so that typically that is the most often encountered distribution in practice. But if some application needs that, you don't want to grow the density e per minus x square. If you want the density to grow with e per minus x, right? That's where this things come, right? Then you can substitute the Gaussian with Laplacian. You want it to be symmetric, and that's the main difference. If I make instead of x, if I make it x square, it becomes Gaussian between Laplacian and this Gaussian. Mm, okay, so yeah, this is very simple. This is very simple. If you identify what is the random variable whose uh, moment generating function is this, right? So this moment generating function is for a Poisson random variable with parameter mu. And you know that for Poisson distribution, mean is if mean is mu, variance is also uh, mu only, right? And sigma is nothing but square root of 4, that is 2, right? So let's see what is the solution. Uh, Here also I made some error, right? Sigma here I have made. I hope you This is also a little bit blurred. Sorry for that. Right. Looking at this mx of t, you should identify this is Poisson with mean 4, and standard deviation will be 2. So I made a typo 4. Okay. And now all you need to do is substitute the sigma as 2 and mean as 4 here. Okay. And so what you get here is 0 is less than x is less than mu plus 2 sigma. That is 4 plus 2 times 2. That is 8. 0 to 8. Okay. So that's it, right? Here you have to sum it from. So here it's a typo actually. So already it's taking minus 3 for Poisson is not defined, right? The Poisson is this is defined only for this positive side. So actual limits are this is 0 and this is 8. Okay. So yeah, that's my bad. I should not have written this from minus 3. I should have written this from 0. And the positive side is not 10, it is 8. This is because I explained that sigma I have taken as 4. I should have taken it as 2. Mm, yeah. So I mean the crux here is to identify that from mx of t that the random variable is Poisson. That's it. Clear, right? What error I made. I have taken sigmas as 4. I am supposed to take sigma square as 4. Yeah, so when I upload this to PDFs there, right? Be mindful of these typos when you look back at some point if you look. Okay. I think that's it. I have for today. Uh, yeah. So let's stop the recording.